All right, good morning, everybody.
Good morning.
Good morning.
Yes. All right, so today we're going to continue on, addition. No, I mean solving rational equations that we started Tuesday. Okay. So let me get stuff out, textbook out. Share my screen, textbook out. Math. All right, so expressions, that is 2.6. So last time, we saw what to do. We said we have to multiply each term by the least common denominator, do the simplifying, and that was the easiest way to do it, right? We said that was the easiest way to do that. So we're going to continue on that. So let's take a couple of examples, and then you're going to try to do them by yourself, right? That is one example. So I'm going to let you like a few minutes trying to do that. That is another example. All right, so I'm going to let you like everybody, I'm going to let like, at least 10 minutes, everybody try to do these 3 examples, the best you can. And then we're going to go over them after that.
Wait.
All right, so I'm going to give it still like a couple of more minutes. All right. So I think, you know, we have enough time to go over them, some of them at least. So let's see, who's gonna please, who's gonna take us, you know, with the first one, what they did, what are the steps? Somebody, please.
I can take the first one.
Thank you, Katie. Go ahead. What you did first.
So first of all, the denominators have actually already been sort of neatly factored for us because x squared minus 16 factored is x minus 4, x plus 4.
Thank you. You see, we factor whatever denominator needs to be factored, and x squared minus 16 happens to be x minus 4, x plus 4. That is right. After that, what is the LCD then? After factoring, what is the LCD?
The LCD would then be x minus 4, x plus 4, which means you have to multiply the two remaining denominators by the other factor that they aren't.
Exactly. You see, the LCD is x minus 4, x plus 4, right? Because it happens to contain everybody. And now, slightly different from what she said, which is actually the same thing. So let's choose to do this. Let's choose to do x minus 4, x plus 4 everywhere, right?
Right.
I mean, let's show the step, right, Casey? That is the step, okay? X minus 4, x plus 4. Now, if I show that, what you're gonna do? For example, the first fraction, what you're gonna do?
You can then eliminate both instances of x minus 4, but you still have to distribute the 7 into the x plus 4, which would leave you with
Exactly.
7x plus 28, I believe, if my math is right.
Yes. So we're gonna write the step and then we're gonna distribute. Everybody see that? We crossed out, KT crossed out the x minus 4. Now we have x plus 4 remaining and the 7. And the second one, which one you're gonna cross out now?
I'm gonna cross out the x plus 4 and
X plus 4.
distribute. to be 3x minus 12.
Yep. So 3x minus 4, right? So we're going to distribute in the next step. I agree with you, right? So now, what is on the right side? What is you going to cross out now on the right side?
On the right side, you're going to cross out everything but the 22.
Exactly. You see, these two cross out, so we have only 22 left. Now we're going to go ahead and distribute, right? So you said this is 7x plus what?
28.
Plus 28. Okay. And here we're going to be careful with the negative sign. You see, minus 3x.
And then plus 12 because the
Plus
negatives
12.
cancel out.
Yep, the two negatives become positive. Plus 12 equal to what?
22.
22. Now, what you did next?
Next, you combine like terms. 7x minus 3x is 4x.
That is
And
4x, correct?
28 plus 12, I believe, would be 40.
40, that is right. Equal to what?
22.
22. And now next, what you do now? You're gonna?
I believe you can, we're trying to solve for the x, correct?
Yes, yes.
Then we're going to subtract 40 from both sides.
Yep, you're gonna subtract 40 from both sides, right? So we get 4x equal to negative 18, right?
Correct.
And then we're gonna divide by?
4 on both sides.
Divide by 4 on both sides, right? So that is my final answer right there. So I can simplify a little bit, negative 9/2, right? You see, without mistakes, that is the answer we're gonna get, without mistakes, all right? So thank you very much, Casey. Everybody see that? The LCD, very important. We got the LCD, you multiply each term by the LCD, and then you do the crossings, right? That is the easiest way to do that, all right? Okay, how about somebody else? Thank you, Casey. Somebody else?
I can do the next one.
Okay, go ahead. Thank you, Peggy. So what you did first?
I factored the x2 minus 25 to x minus 5, x plus 5.
That is right. Okay.
And then the LCD is x minus 5, x plus 5.
That is absolutely right. Okay. And
So
next.
I put it on the top of each one.
X minus 5, x plus 5. X minus 5, x plus 5. And x minus 5, x plus 5, right? Now
So
the first one, go ahead.
On the first one, I factor out the x minus 5. So I just have x plus 1.
Yeah, so the x minus 5 is gone. So I have 1 times x plus 5 left, right? The second one,
The x
gone now?
plus 5 is gone.
X plus 5 is gone. We have 1 times x minus 5 left, right? On the right side now, who is gone on the right side?
Everything is gone. X minus 5 and x plus 5. Only the 10 is left.
Only the 10 left, right? Now, next, of course, now, distributing the 1 is like doing nothing, right?
Yeah, it's just x plus 5. Plus x minus 5.
Yep, equal to
10. So I mark out the 5s.
Yep, the 5's gone.
2x equals 10.
Yep, and then
divide by 2 on each side. So x equals 5.
X equals 5, right? So are you done? That is it, right? Okay.
Yeah.
So now, if I tell everybody that is not the correct answer, what you gonna tell me? You're gonna tell me, am I crazy? That is not the correct answer. So what would be the reason? What would be the reason that is not the correct answer? What would be the reason? That could
Would it equal to 0?
What's going to be equal to 0? You are on the right track. What is going to be equal to 0 when you substitute 5 inside?
Oh, I see. It'll be equal to 0 and the like x minus 5, x plus 5. Well, the x minus 5 will be 0.
Yes, the x minus 5 will be 0 on the denominator, right?
Okay,
now, can we have a 0 in the denominator?
No.
We cannot have 0 in the denominator, right? So what's
Yeah.
going to be my final answer then? Since 5 did not check out, you see 5 here, my calculation is right. Your calculation is right, Peggy, right? But 5 does not check back. When you plug in 5 in the first denominator, for instance, you get 1/0, right?
Yes.
Every time that happens, your solution is a fake solution, you see? So we didn't take a second to talk about it here because clearly negative 9.5, which is negative 4.5, does not cancel, does not make anybody 0 here, right? What are the two numbers that are going to make 0 is the first example? What are the two numbers that we don't like? Okay.
Either -5 or +5.
Yes, -5 or +5 in the second example. In the first example, -4 or +4, right?
Okay.
Every time you get those, you cannot take them as solutions. You see, this one does not check out. So we get do this. We say no solution.
Yes.
All right. Again, everybody understand why it does not check out, because when you put 5 here, make it 0. Okay. It makes the denominator 0, and that we cannot have. We cannot have it to become 0, right? That's the only reason. But the calculation was right. You know, everything in the calculation was right. Okay. All right. Thank you very much, Peggy. So the last one will be maybe the longest one, right? And the reason is we have x's on the numerator. You see, because of that, because of the fact we have x's on the numerator, the last one, yeah, when I said, you know, the solution was a good one, you know, looks like I was crazy. Say because the calculations was all correct, right? All right. So if you do my open math and you do the right calculations and then you put the answer and my open math tells you, no, think about it, right? Think about maybe my answer is not a good one. Maybe my x does not check out. Okay, the last one now. This is the last one will be the longest, okay? Because of the fact we have the x on the numerator. So, but it is on the same way. So x plus 1, no need to factor. X plus 3, no need to factor. But this one happens to be x plus 1, x plus 3, okay? Because the two numbers that add up to 4 multiplied to 3 are 1 and 3, right? So once we get that, what we do? We do the same thing. So we're gonna put, you know, x plus 1, x plus 3 here. So we're going to cancel the x plus 1s. We have x, parentheses, x plus 3 left. Minus, we do the same here, x plus 1, x plus 3. We have x plus 3 gone, minus 3 parentheses, x plus 1. Equal x plus 1, x plus 3, both gone, equal -2x squared. All right. So now what you have to do now, we have to do the same thing. We have to distribute. This is x squared plus 3x minus 3x minus 1 equal to -2x squared, right? So here, these two cancel out, right? We get x squared minus 1 equal to -2x squared, right? I mean, I'm sorry, this is -3. Right
Is
here.
it -3?
Yeah. Thank you very much. That is -3. See. So what's going to happen is we're going to remember, if you want to solve, this is called a quadratic equation, right? Because it has x squared in them. The only way so far we know how to solve quadratic equations, the only way we know is by factoring, right? Do you remember if you want to solve the equation by factoring, do you remember what you need to have on one side?
0.
0. We need to have 0 on one side. Thank you. So which means we have to, for instance, add 2x squared, add 2x squared here. So we're going to do this. These two gone, we get 0. And here we get 3x squared minus 3. Now, can you proceed now?
What?
Can you proceed? Can you continue the 2 steps to
No.
solve this? 3x
Yeah.
squared minus 3 equal to 0. What should we do next?
We pull the 3 out.
We pull the 3 out. That is correct. So we get 3 parentheses x squared. You see, we divide by 3, divide by 3, x squared minus 1 equal to 0, right?
Yeah.
And next you're gonna factor, right? Okay, how you factor x squared minus 1?
X minus 1, x plus 1.
Thank you. X minus 1, x plus 1 equals 0, and we have 3. So now we have to set everybody to 0, right? That is x plus 1, I'm sorry. Can we set 3 to 0? We cannot, right? 3 is not 0 for sure. So the 3 is gone, right? Because 3 is not 0 for sure. So 3 cannot be 0. So that's why you can forget about 3. Or if you want to know why, if you divide both sides by 3, what's going to happen? If you divide both sides by 3, you see? 3 over 3 is 1, is gone, right? And 0 over 3 is still 0, right? Okay. That is why 3 is not relevant. Now we have x minus 1 equals 0, or x plus 1 equals 0, right?
So it's
You
x
add 1,
doesn't
add
have
1, so we get x equal 1, or minus 1, minus 1, you get x equal negative 1. So here, very likely, I have 2 solutions, but before I adapt these 2 solutions, before I say, these are my solutions, what I need to check? What do I need to check?
plug them back in and make sure it works.
Yes, make sure it works, or at least make sure they don't make the denominator 0, right? Okay, make sure they don't make no denominator become 0. Okay, so for instance, if you take 1, look at the original. When you put 1 in all the denominators, 1 plus 1 is 2, right? Good. 1 plus 3 is 4, good. 1 plus 1 times 1 plus 3 is good, right? How about negative 1? When you, the first denominator, negative 1 plus 1 is how much? Is 0, right?
0.
I stop there. I even don't need to proceed. Negative 1 is not a good solution, okay? So the only good solution we got is x equal 1. All right, so you see, this is how you solve rational, the easiest way to solve rational equations. That is the easiest way to solve rational equation, all right? Find the LCD, multiply everybody by the LCD, and then, you know, solve for x. All right. Do you have any questions on that? So after that, so we're gonna start, you know, the next topic here, which is some word problems, right? Okay. So I know people don't like them a lot, but you know, we're gonna try to see we're going to try to see, for instance, okay, that is 1.2.7. Motion and work problems. These are just applications, right? So for instance here, we say, we're gonna start with the work problem first. Okay, so let's see this example right here. Okay, look, that is a problem we have. All right. They say Pat can paint a room in 3 hours. Right? Les, is that Les? Yeah. Les can paint the same room in 6 hours. Okay. How long will it take them to do the job together? You see, that is not like a straight answer. You see, you cannot just look at the two numbers and say, okay, they need 2 hours or they need 1.5 hours. It's more complicated than that. You see, so don't try to figure out the answer just like that because it will not work. So what number comes to your mind? You know, just trying to figure it out. Okay, Pat can do the job in 3 hours. Les can paint the same job, do the same job in 6 hours, right? If they work together, how long is it going to take them? What number comes to your mind?
At 4 or 5.
Well, Pat alone can do it in 3 hours. So if she get help from Les, of course we expect together, we accept the time to be less than 3 hours, unless they distract each other, right? If they do not distract each other, the time they will need will be less than 3 hours, right? Maybe 2 hours, maybe, I don't know. You see, the answer, you're gonna see the answer is not as straight as we can think. We cannot just look at them and say, oh, they will need like 2 hours or 1.5 hours. It is less straight than that. So let's try to do that. So basically, we will have a rational equation to solve, right? That is an application right here. So let's say that is a job right here. This is a job. This is a job, right? So Pat can paint the job in 3 hours, right? It takes Pat 3 hours to do, 3 hours. Okay? So each hour, what is a fraction of the job Pat does every hour? What is a fraction of the job Pat will do?
1/3.
1/3, right? You see, everybody agree with that? If you complete something, if you need 3 hours to complete something, every hour you're gonna complete the third, right? Okay, so Pat will complete each hour 1/3, right?
Mm-hmm.
Okay. For Les now, the same job, you see, same job right here, but now Les needs 6 hours. Every hour, how much Les completes now? What fraction of job Les completes every hour?
1/6.
Everybody agree that 1/6 each hour?
No, 1/3.
Okay. Les, which is Les has
Oh, sheesh. Never mind.
is less efficient. Less is less efficient. That's right. You see, less is less efficient, and he completes the job every hour. He only contributes 1/6, right? Pat completes 1/3. Okay, now together now. Together. They need, how many hours they need? We don't know, right? Together they need X hours. Okay? They need X hours together. But I don't know how much is X. Since they need X hours, every hour, how much fractions they're going to complete, depending on X?
1/3 and 1/6 equals 1 hour.
Yeah, you see, we're gonna, yeah, there is, you know, so we're gonna establish the equation next. But if we just look at, okay, let me ask a question like succession of questions, and you're gonna see. If I need 4 hours, every hour, how much? What is the fraction I will complete? If I need 4 hours,
1/4.
1/4. If I need 7 hours, every fraction, every hour, how much I complete?
1/7.
1/7, right? Okay. If I need 19 hours, every hour, how much I complete?
1/19.
1/19, okay. Now, if I need X hours now, every hour, how much I complete?
1/x.
1/x. Same thing. 1 divided by the number of hours, right? You need. You see? So here, together, each hour, they're going to complete 1/x. Together, right? Okay. So now that 1/x now, you know, from what you said, Noel, that 1/x must come from the contribution of Pat and the contribution of Les, right? How much Pat contributes? 1/3, right? How much Les contributed?
1/6.
1/6. So when you add up 1/3 plus 1/6, it should be equal to the 1/x. The blue plus the red should be equal to the green. That's how we get the equation, right? So the equation says, because it is a contribution, so 1/6, 1/3 plus 1/6 must be equal to 1/x. That is the equation right here. You see, 1/3 plus 1/6 equal to 1/x. Okay, and now we solve it. So, what is LCD? The LCD is a little bit less than 18 because 6 and 3 are related, right?
6.
Is 6x.
Oh, just kidding.
So it doesn't make it wrong if you consider 18x. Your calculation will be still right. But if you want something that is simplified, you go with 6x, right? So what you do next, we're going to multiply by 6x, multiply by 6x, multiply by 6x, right? And then we're going to divide 6x divided by 3 is 2x. 6x right here plus x equal to 6. You see, 2x plus x is 3x equal to 6. We divide by 3, divide by 2, so we get x equal to 2 hours. Together, they will need 2 hours to complete the job. Okay? And the equation here, what you have to remember is, look at how we got the equation. Look at the equation we got, right? 1 over the time of the first person plus 1 over the time of the second person equal to 1 over x, which is, you know, the time they have to do together. So we have like 2 equations. We have 2 forms of the equation. We have 2 forms. For the equation. So the first form is 1 over 3 plus 1 over 6 is equal to 1 over x. What is the second form? The second, look, if you multiply here by x, if you multiply everybody by x, what you get? You multiply by x here, you multiply by x, you multiply by x, what you get? X over 3 plus x over 6. X over x is how much? Is 1, right? So either this is the first form or you go with the second form. Which form is easier to remember? Which form is easier to remember like 2 weeks from now? Which one is easier to remember?
I think the first one.
The first one, 1 over 3 plus 1 over 6. I can't agree with that, right? 1 over 3 plus 1 over 6 equals 1 over x. Okay. But they both are the same form, right? You see here sharing, this is what you call sharing a job. This is the type of equation we get. So right here, if we say an example here, we say John needs 5 hours to grade papers, right? Matt needs 7 hours to grade same papers. How long if they get together? You see, this is this type of question you're gonna have. If you remember the equation, then you have some easy stuff to do. If you remember the equation, right? Okay. All right, so try to do that. Try to mimic the equation we got previously. So the issue here is to write the equation. That is the first issue. If you don't remember the equation, getting the answer will be very hard, right? All right. What is that equation? What is that equation?
1/5 plus 1/7 equals 1x.
Exactly. 1/5, that is the equation. 1/5 plus 1/7 equal to 1 over x. You see? So, and then you solve for it. I mean, you solve the equation. What is LCD?
35.
35x, right? The LCD is 35x. So what you do? We multiply by 35x, 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 right? Now 35 divided by 5 is 7. So we get 7x plus 35 divided by is 5 plus 5x is equal to 35. Okay, which is 12x equal to 35. So x equal to 35 over 12. Okay. So again, you know, if somebody wants to be able to solve these problems, if you want to be able to solve them, you have to remember the equation. If you don't remember the equation, I don't think you can come up with a number like that. Okay? I don't think so, in general. But the equation is easy to remember. It's 1 over the first time plus 1 over the second time is equal to 1 over x, right? 1 over time number 1 plus 1 over time number 2 equal to 1 over x. That is how we remember that equation. You see? So that is the first application. Now, in the second application now, we have the motion problems. So do you remember, like, you know, these physics formula? Let's say the distance is the speed multiplied by what? Is the speed times time, right? Okay. Or the speed is also called the rate, right? The speed is also called rate. So, or velocity or something like that, you know. So right here, if you are doing 60 miles per hour, right? You are doing 60 miles per hour. What is the distance you're gonna do after 5 hours? What you do to get the distance? After 5 hours, what is the distance you did cover? Somebody.
You would multiply 60 by 5.
Exactly. Somebody is doing 60 miles per hour, right? 60 miles per hour for 5 hours. What is the distance going to be? Distance going to be 60 times 5. That's it. It's 300 miles. After 5 hours, you're going to cover 300 miles, right? You see, the distance, the speed is also called the rate. Also. So this could be written 3 ways. So we said the distance is speed multiplied by time, right? What is time is equal to then? From the same equation. If you want to get the time by itself, what you do to both sides?
Distance divided by rate.
Exactly. If you want to get the time by itself, you divide both sides by the rate. It's going to be distance divided by the rate, right? Or the other way around, what is the rate is equal to then? If you want to get the rate by itself, from
Distance
the
divided by time.
distance divided by time, that is correct. So basically, mathematically talking, how many formulas I see here? I
3.
see 3 formulas, but they all express exactly the same thing. I cannot see one. You see, it's like seeing one person with 3 different clothes, right? It's the same person. So this is the same formula. The first one we got distance by itself. The second one we got time by itself. The third one just rate by itself. That's it. But it's the same stuff, same formula. So now we can have this type of questions now. All right, so we have this one. You see, a powerboat travels upstream for 50 miles. In the same amount, it travels 80 miles downstream. If the speed of the powerboat in still water is 65 miles per hour, find the rate of the current, right? What is the speed of the current or the rate? So right here, why this difference between the, between the distance traveled? Why is the difference? Why upstream is 15 miles only, and downstream is 80 miles for the same time? Why?
Because of the current.
Because of the current. Thank you. You see, because of the current. So basically, so we have 2 ways. The first way right here, this is a boat, right? The boat goes this way. Upstream, this is only 50 miles, right? Why? Because the boat has to battle. You see, this is the speed of the boat. It has to battle the speed of the current, right? The boat has to battle the speed of the current. Okay, so now let's see an example. If the speed of the boat is 65 miles per hour, right? If the rate of the current is 10 miles per hour, what's going to be the net speed if the boat is going upstream?
75 miles per hour.
Upstream, you see, upstream is the speed of the boat will battle, right?
Okay,
The
so
speed of the
minus.
current is a minus, right? So the net speed will be 55 only, right?
Mhm.
Okay, the net speed upstream, the net speed will be 65 minus 10 will be 55. If the boat is going downstream now, what's going to be the net speed now?
You would add it.
We'll add downstream. You see, so downstream now, if the boat is going this way, right? And the boat is going this way, and it did what? It did 80 miles this way. Why 80? Because this is the speed of the boat is going to be helped by the speed of the current, right? They both go the same way, okay? So now we have to add them up, right? Okay, so now we don't know what is the speed of the boat. I mean, the rate of the current. Let's call it V. Let's call V is the rate of the current. If V is the rate of the current, then upstream, the net rate of the boat will be equal to 65 miles per hour minus V, right? And downstream, the net rate of boat will be 65 miles per hour plus V, right? Okay, so now let's do this right here. Let's do this type of small table here. This is upstream. This is downstream. This is a distance. This is a rate, right? And this is a time. Okay, look, how much of the distance the boat was able to cover upstream? How much of the distance?
50 miles.
50 miles. Downstream, the boat was able to cover how much?
80 miles.
80 miles, right? Upstream, what is the net speed of the boat?
65 minus V.
65 minus V, right? By the way, everybody understand why that? I mean, common sense, when you are battling the current, your net speed is your speed minus the speed of the current, right? If you are battling, if you are going against the current, when you are going with the current, your net speed will be the 65 plus V, right? Because the current is helping you. Now, what is the time now? What we say the time was equal to, the formula for the time? Is distance divided by the rate, right?
Mhm.
So the time is distance divided by the rate is 50 over 65 minus V. And here it is 80 over 65 plus V. All right. Everybody understands this table? If you don't understand this table, you tell me which part you don't understand and we try to go over it, right? I don't have an equation yet. You see, I have my table, my nice table, but I don't have an equation. I have nothing to solve yet. Tell me, what sentence here, what sentence in the problem allows you to have an equation, allows you to say this equal to this? What sentence? What part of the sentence allows you that?
This is find rate of the current.
That is the question, right? That's define V. But I need me an equation to solve, right? I don't have an equation yet. What part of the question, there's a very important part of the question, like a couple of words that give you the equation.
Is it when it says that 50 miles is it travels 50 miles in the same amount of time that it travels 80 miles?
Thank you very much. Same amount of time. The two times must be equal, right? Same amount of time. Look, it means this time right here must be equal to this time. That is my equation, right? same amount of time. Okay. You see, that is my equation right there. Now I know how to solve this one. What is the easiest way to solve this equation? Is to do the cross multiplication, right? So we get 50 parentheses 65 plus V is equal to 80 parentheses 65 minus V, right? Distribute. How much is 50 times 65? 3250, right? Okay, so 3250 plus 50V equal to 65 times 80. How much is that?
5,200.
5,200 minus 80V. Now you need to have all the numbers alone and all the variables alone. So to get all the variables alone, I add 80V, and then I subtract here minus 3250, minus 3250. So the 80 is gone, Z is gone right here. So we get what? We get 130V is equal to 5,200 minus 3250, which is 1950. And then I divide by 130, divide by 130, divide by 130, so I get V equal to 15 miles per hour. That is the rate of the current, right? 15 miles per hour. All right. So for the test, for our test, our test this Tuesday, I will not ask about this stuff, right? It's only what is on the review sheet, okay? Only what is on the review sheet. So I will not ask about this for the test, All right, so everybody, you can write your name. Yeah, I mean, it could be a word problem, but not in, it could be a word problem, but not in this section. Remember the word problem, when we launch a ball, right? And then it's come down to the ground and we ask how long it's going to take the ball to hit the ground. That type of word problem could be. It is in the review, by the way, okay? But for this one, for this type of word problem, what we did today, we're going to wait for test number 2. We're gonna wait for test number 2. So everybody, do you have any questions? Please do not miss the test, right? Don't miss the test. Tuesday, okay, it's gonna be on Zoom, except for those who have, accommodations and who need to go to the testing center, but everybody else is gonna be on Zoom. Don't miss the test, Missing an assignment, like a test, is really a 0, right? Until somebody proves otherwise. And it's not like, you know, the proof why I missed the test is not like, okay, just a verbal stuff. No, it has to be something written. So don't miss the test. That's, you know, that is my advice. Okay,
Is that
so
our regular meeting time? 11:10?
yeah, it's gonna be the same meeting time, 11:10, right? We're gonna come probably, maybe I'm gonna take like, you know, 5-10 minutes to talk about it a little bit, you know, and then, but you know, if you want to prepare for the test, the review indicates the topics. You have to be able at least to know each problem in the review. You have to be able to know how to do each problem independently in the review. And then you can practice other problems if you want, right? So, but at least those in the review, you need to know them. And it's gonna be on Zoom, everybody gonna have their camera on, and you're gonna show me, you know, you know, the workstation, like, so, all right. Thank you very much, and see you Tuesday.
Thank you.
Hi, everybody.
Bye.
Thanks for class. Have a good day.
Thank you.
Bye-bye.
Bye. Yeah, remember, I also have my office hours, you know, if you need help.
When are they?
My office hours are Monday to Wednesday and 10 to 12. That's my office. So now, if my office hours do not suit you, like I said, when you go to the Bright Space, right?
Mhm.
If you go to Bright Space, you go to your class in Bright Space. You have, so let me show you. So you see, on Bright Space, when you go there, you have this. This look right there. You see,
Oh yeah.
the math center. This is a good help because this stuff is done by CCBC teachers.
Okay, they tutor you online?
Yeah, they tutor you on Zoom or Teams.
Okay, that's what
They
I'm gonna
do. Yeah, they really do.
Okay.
And if you look at the schedule, you always have, it's almost 24. I mean, it's almost the whole day. You see. So every day right here, see, that is the schedule right here. For instance, you want to go right after class. For instance, this is like Thursday right here. You see, 9 to 10, 11 to noon, noon to 2, 5 to 6, right? And when you
Oh,
click here, you right click, you open the link. It's going to bring you directly to the teacher who's there, and they're going to have 1 hour to tutor you.
wow.
Yeah, it does help because my office hours, like, you know, I'm busy Tuesdays and
Yeah.
Thursdays. That is why I couldn't do office hours on those days. But Monday and Wednesday, I have 10 to 12.
Yeah. I
Alright.
would definitely take your office hours, but I can't. So I'm gonna have to
I understand.
yeah.
I understand. All right. Thank you very much.
Thank you. Oh, I have a question about the homework. Are
Yes.
those all those problems they're due tomorrow? Or no, October 1st, right?
Let me see. Let me check my open math. So this does it say they do tomorrow?
Because I feel like I remember you saying something about the homework problems being due in October, but maybe it wasn't the first.
Yeah,
Maybe.
well, I mean, when you click on it, it shows what is the date. It's I think it's October the 10th.
Oh, the 10th. Okay.
Yeah. When you click on it, it shows October the 10th.
Haha. Yes. Now I won't have a heart attack. That's good.
Okay.
Okay. Thank you, Professor.
You're welcome.
Have a good one.
You have a good one. Thank you.